Good morning, guys. Welcome to Astronomy 120. This is for the late start section that started this past Monday. Today is Wednesday, September 17th. The class started on Monday, September 15th. So this is a late start class. The discussion that is for today is specifically geared toward the general introduction of the class and some key important information related to it. And some of you already messaged me about a couple of issues. One issue which has to do with the due dates. I already fixed that. And so that we can get our great semester. Anyway, so again, my name is Buzidi. I'm your instructor for this class. Some of you are already sitting in my other astronomy class, the labs version of this class, which is Astronomy 125. And I know they express kind of basically the fact that they will not be able to attend the live session, and that's fine. I mean, this is a recorded session anyway. So because it's scheduled at 9 a.m., some of you have other classes, some of you have other things to do. So it is recorded. If you did not attend, and if you're not attending this one live, you make sure you finish the video all the way to the end so that you see what's going on. The plan is in the future, we will have also other meetings. If you cannot attend the meeting live, don't worry about it. The meeting will be recorded. You will be required, though, to watch the recording afterwards. So I will show you where these things usually go. They go toward the end of each week, each session when it's held, so that you go later on and you watch it. You also need to watch for messages that I will be sending in general, regardless of what the purpose is, but specifically related to class sessions and things like that when we meet and things like that. You will see some very, very important dates, some very important assignments. As we go along, you need to make sure you're keeping up with what's going on. Anyway, so let me share the screen to see the class online because this is an online class. So let me share this link. I hope you guys are looking at the same thing I'm looking at, namely the fact that I'm looking at your class. It says in here, Astronomy, Introduction to Astronomy, Section 71. Okay. This is the land page. I'm looking at it from the vantage point of a student. I don't know if you can see in the bottom. It gives me the option to leave the student view because I am inside the student view. Basically, this is how it looks to you. Okay, so this is, I'm looking at it from your vantage point, from your perspective. So anyway, this is the landing page. There are some important links on the landing page. Okay, basically, it's a lot of the information is actually in the syllabus. So, and the syllabus is actually also, I already sent you that last week. I remember that because you should have received an email from me. But there is a PDF version, which is the same version that you actually have received. And it's in here. So this is the link to it. You can download it. It says Astronomy 120, Section 71 syllabus for the fall of 2025. You can download it there. There is also actually another link in here that takes you to the online version of the syllabus, which you can click on and you go to the link there. And you can actually also access it from this side too. So there are many versions, many ways of getting to the same point, namely to the syllabus. So whichever way you link to it, whether through here or through there, that gives you the online version. Here will give you the printed version, basically the PDF version that you need to access. So let me click on the syllabus in here. It doesn't matter which, as I said. So I'm going to click to the online version. And basically it gives me general information about my contact info. This is my email of how to contact me. It also has my phone number in my office, which when you call, basically what it does is it's going to send me a message saying that you have received a message. Because I really don't have a physical phone in my office, so I will be notified later on that you called. But this is actually my email address, which is also, I usually respond to it immediately because it's on my phone, it's everywhere. So I have access to my email all the time. Another way, and actually the best way of getting a hold of me, is to actually come in here to the left pane in the class and send me a message. Granted, if you have difficulty accessing this class online, you will not have access to that, but you already should have received an email from me with a syllabus, and that includes my email address. Now, if you have a problem, and I know if you do, you're not here, but at least in info so that it goes away to everybody else in the class, that you need to send me a message saying that, hey, I can't access my Canvas shell because that's where the class is happening. That's where all the assignments are. That's where all the testing is. So if you can't access it, you're not going to be able to take this class. So in that case, I will refer you immediately to tech support to make sure to resolve whatever issue you have. Anyway, so you need to access the class. Once you do, this is the place that I prefer, honestly, that you would come and message me. So you come in here to the left pane where it says inbox, you click on it, and then you send a message to me or to one of your peers. Okay. So when you send a message from here, it tells me a lot of things. First of all, it tells me, of course, your name in detail. And like an email address, some of you, for example, would, I don't know, they have their favorite bike or their favorite dog or something. That's their Gmail address. If you send me an email from them, I have no clue. First of all, if you're a student or somebody else who's trying to spam, and if it's a spam, probably I will not be even able to see it, let alone, I mean, it goes directly to the junk folder. So here, when you come from the inbox, give me the full name and probably your ID and all of the information that I need to make sure that you are unique. You are who you are, number one, and you are a student in here. Give me all the details about your information. Not only that, it tells me which class you are in, because I have three sections from Astronomy 120, in addition to three other sections going on, basically two for the lab and another class in physics. So if you tell me that your name is Andrew or John or Sarah, there are so many of Sarahs in in these classes. It's very hard for me to find who you are or which class it is. And even if you tell me you're in an astronomy class, I have a combination of five sections altogether, so it's very hard for me to zero in on which class you are in. But if you come from the inbox, granted, probably in the same class you might have two people, but I already have your first and last name, so I know exactly who am I dealing with and which class. So if you say you have a problem with homework two, for example, problem three, then I know which class we're talking about, which homework we're talking about, and who you are, and I have a lot of insight into your question or your what you need help with. So it's much easier and much better for you guys to communicate to me through the inbox whenever you have a question. You want to know if the due date, for example, of the midterm has been changed or something, or you didn't get a message, or the review, when is it going to close, or if you need help with the review or something. This is the place to come and ask that question. And again, my email will pop up immediately that somebody sent me a message via the inbox, and whatever question that you have is going to come up in the email, in addition to the fact that it's going to come to the inbox. And also, I'm always logged in into my shell, so I always see exactly who's sending what. So again, the best preferred way for communication in this class, or any of my classes, as a matter of fact, is to come to the inbox and send me messages. If that fails, which is unlikely, then you have the option to send me an email directly using my email address or call this number. This is, like I said before, this number rings in the office, and that number actually is the one that is that also I will be notified immediately about it. Anyway, so these are the ways of communicating with me via email, via the inbox, I mean the phone number, or via the inbox, which is the preferred way of communications. I can't access it right now because I'm logged in, as I said before, as a test student. And a test student has no email address. So if I try to go to the inbox and it's going to throw an email, throw an error. But the point being here for you, this is the best place to send me messages. So whenever you have a question, whenever you have an issue, whenever you think the deadline is not correct or something is not right, this is the place to ask for it. If you need the help with the homework, if you think the quiz is not long enough, or I mean the time is not enough or something, this is the place where you come and ask for it. Okay. So again, this is the inbox, and I prefer that you go in there. It gives me a lot of info into who you are, which class you're coming from, and what kind of help you need. Okay. So that is one way, that's how we communicate. There is another piece of information in the syllabus, and that is my office number. My office is in the physical science building, room 195. If you're not familiar, first of all, you need to come to the campus. You need to get to know the campus. On the north side of the campus, near where the high school on the other side is, there is the physical science building. Okay, it's near parking lot number 4, and it's actually not too far from the administration building. So that's where the physical science building is, and it has it's like an angle at 90 degrees. It's two sides to the building. Actually, it's like more like a lowercase t, I guess. Okay. So you have a long side, which is the old physical science building, the main building, and this has 3 floors. And then you have the new extension, which is actually 2 floors. It's in the new extension. On the first floor is where my office is. It's kind of hard to get into it a little bit because when you start looking for room 195 and you walk the hallways, you will not see it in the hallways at all. But what you will see room 194. I'm sorry, you will see room 196, and then it jumps to another number, 199 or something, and before that it's like 192 or something. So there is a jumping, meaning that you have to go through that door first, which is sometimes is locked. So if I'm not there, or if there is no person in there, so the room could be locked. Uh, and then you will find room 195. So room 195 is inside inside another room. So it's part of another 3 rooms actually inside that section. Which brings me to an important point. Although these are my office hours listed in here, you really have to let me know that you're coming. One of the problems is this one. I may open the office, that section, that building, that section of the building, but somebody else, another faculty, for example, because he or she has a grading to do, or has testing to prepare, or has other things to do, because there are some adjuncts faculties to sections for them, and another full time on the other side in my office. So there are 4 sections in there. So another person could come in and lock it. And also there is a copier machine, and they have all kinds of materials in there, and sometimes they do lock it. So you come in there unannounced, I don't know you're coming, and although it's an office hour, let's say the Tuesday, you come in at 8:30, for example, in the morning, and I don't know you're coming. I opened the door already. Somebody else came after me and they locked it. And you come in there and you cannot even knock on my door. You're way outside. Okay. So I wouldn't even know that you're there. Okay. So my recommendation for you guys is to immediately send me a message whenever you think you're coming. First of all, to make sure I am in that room and the door is open for you. Second, to give me a chance to make sure that to prepare for what question you have. So send me a message ahead of time, again, preferably via the inbox, who you are, which class it is, what kind of help you need with, and tell me, hey, I have a free time, for example, on Wednesday around 3:30. Can I come in for help for office hours? Most likely there will be no problem because, well, especially in the beginning of the semester, not around testing times, most of my office hours are free. So there will be no problem. So I'll tell you, fine. Okay, we'll meet you there at 3:30. I'll make sure that the outer door is open. My office also is open, and you're welcome to be served. Now, if none of these times work for you, including the Zoom session on Monday morning, because it's at 9:30 in the morning, if none of these times work for you, that's fine too. You can say, you know what, I need help and I really need to meet with you in person or on Zoom, and I can't do it. Those times they don't work for me. I have other classes, I'm working, I have other things going on. So I can't really meet with you. Is there another time we meet? And that's fine. We can always find a time. One of the times that is not listed here, for example, on Wednesday morning, I can meet with you on those times too. I can find a time. If none of these dates work for you from Monday to Thursday, we can meet on Friday. I mean, I know I am engaged with a lot of activities with the college that involves other things going on with committees and things like that. But I have Fridays in the morning open a lot of the times. So if that's convenient for you, we can meet on that time. If none of the weekdays work for you, we can even arrange for the weekend. We have to be careful though, because sometimes I will be out of town or doing some other things. As long as you message me, we will find a common time for us so that we can meet. If we can't meet in person on campus, we can still meet on Zoom and basically resolve whatever issue that you have. So that's not an issue. So the point being in here is two things. First of all, if no times are working for you, we can always meet, whether in person or online. The second is send me a message ahead of time, please, and so that we can arrange at least to make sure you don't waste your time. You come all the way from wherever you're driving, and then you come in there and you don't find me because the door was locked. Number one. Number two, I could be wandering somewhere else. I could go to the STEM center. I could go to the office. I could go to the planetarium because one of the sections I'm teaching this semester is Astronomy 120, similar to this one, except it's in personal class. And I have a lot of things to go and prepare for that class. So it's a class that is in planetarium. So I have to go there and physically move things and adjust things and make sure that the projector is working, make sure my cameras are, because I'm recording those classes. So I go a lot of times there too. Or I go to the lab too. I have the lab for my astronomy 125. So sometimes I have to go there to make sure that the computers are fully charged, all the equipment is in place, to talk to the lab assistant to make sure the equipment is ready for them, and also have another physics class too, where I go to another lab and make sure that that class also is ready. In other words, if you come in unannounced, don't be surprised that you will go basically unserved. I hate to see that, but that there is a chance for it that it might happen. Okay, for several reasons. First of all, my availability. There is another chance also that I will be with one of your peers too from another class, not necessarily your class. So if you come unannounced, it's going to be a problem. So please send me a message ahead of time. Tell me you're coming. That way, at least I'll make sure that you can come in because there is a physical handicap in here with this, the way that the office is laid out. So this is basically in terms of how you reach me. This class, of course, is an online class. One thing that you note for this class is a short-term class, meaning it started later than most of the classes, September 15th, and ends a week before everybody else. So it's a very condensed class. It starts later and ends first. So it's a really, really highly condensed class. So you will see a lot of assignments start to be due immediately. Okay, so I know you chose that. Okay, there were other options where class starts earlier, about 3 weeks early, and ends a week later. So you have about 4 weeks extra on those classes than this one. So because you chose this one, which is a highly condensed class, so don't be surprised that the assignments start to come close from one another because we have to meet that deadline. We cannot exceed it. That's college policy. I cannot give you assignments past this due date. So the due date is December 12th. When this class is over, it's going to be over by that date. So we don't have a choice in that. So this is something that you need to be aware of, and I'm sure you were because you chose this class. So you need to pay attention to this point in here. So down the road, please be aware of this fact and don't delay assignments. In other words, I know already some of the assignments that we'll do this weekend, I already postponed them to next weekend because of this very warning that I was going to about to issue. That because we didn't have a meeting last Monday, I was planning actually to have the meeting on Monday, but there was an issue involving me and I had to go for jury duty on Monday. So the earliest we could have a meeting is today, which is Wednesday. So I ended up postponing those assignments that were due this weekend to next weekend. Okay, to this kind to the which the weekend, the next weekend is the 27th, I believe. Yes, on the 27th. So some assignments are due the 26th, others the 27th. So the point being in here is don't delay assignments. So if there is an assignment, start on it immediately, number one, and finish it as soon as possible. Because here is the problem. This is a condensed class. Assignments are naturally going to be closer from one another. And if you compound that with delaying them or even exceeding the due dates, you're going to run into a problem where the problem becomes insurmountable. Too many things to do at once and get out of hand very quickly. You don't want that. Okay. I'll tell you about time management for this specific class because it's different than the normal astronomy classes or any other class that has a regular class schedule. Normal classes, so that you know, on campus meet for about an hour and a half twice a week for a lecture. So you have a 3 hours load, okay? This class, because of the fact that it has that short term, it needs to meet for 4 hours. If we were doing this on campus, we would meet for 2 hours twice a week, a total of 4 hours. So you, on your other hand, are not like the regular started class. Your load is already more per week because you start late and you end early. Okay. So this is a class work. This is a you coming to the classroom and attending and basically taking notes from the lecture. That's it. Those are 4 hours. So minimum from you now on, you have to count those 4 hours every week you have to spend on this class. Okay. You put in your schedule. Let's say, for example, you have class on Monday, you have work on Monday, you have something going on Tuesday, and on Thursday you have something else. You notice that on Wednesday, for example, between 3 and 4, or between 7 and 8, or between 7 and 9, you need 2 hours, okay? You need 2 hours, and you say, you know what? This is dedicated to my astronomy class. You put it in your schedule, and you sit down for that much time and be disciplined. You put away your phone. You don't look at your phone. You don't go and watch YouTube. You don't go into your on your computer and start doing other things, side points. No, that is not the class time because if you are in class, you're not going to be doing that. So the point being in here is you are in class at that time for 2 hours straight. Okay? You may take a breath and break, or you may take something to go and grab something to eat. That's the advantage of having class at home, I mean online. But for that much time, you are in class. And then you have to do it twice. So you schedule your class to be there. I monitor your activity on campus. So if I see a lagging in this thing from you, I will let you know. And if I don't let you know, please monitor yourself too. Because down the road, you'll start saying, okay, I spent a lot of time in the class, but I actually see that you're spending less than 4 hours a week on the class. Then that's not fair. You can't tell me that, hey, I spend a lot of time in the class and I can't still think. No, you're not spending enough time. You spend probably what, 20 minutes on this week? 20 minutes next week, probably 30 minutes, 35 minutes, even an hour and a half. That's not enough. Because if you are in person, that's how much time you're going to do. Now, there will be at times where you can't meet that time. Let's say, for example, next Wednesday I have something going on. Okay, family come in, an emergency here, something happened to the dog. I need to take care of it, so I can't make class on that time. That's fine, as long as it's an exception, not a rule. Okay, because that too happens in a regular class too. In a regular class, you may miss a session. You may for one reason or the other. Your tire is probably needs to be replaced. Maybe you can't find a ride. Maybe you feel tired and exhausted from what happened the night before, or sick or something like that, or you need to take care of a loved one or something. So that happens in the regular class too, where you can miss a class. I'm not saying that if you miss a class, that's it, that's the end of everything. No, that you have to put it in your schedule that this 2 times, 4 hours a week, I'm going to dedicate them to this class. Read the book, watch the videos. There will be videos. Each video is about an hour or so on Canvas. Do the assignment and make sure I complete my 2 hours. Now my 2 hours are done. I can go and do other things. I can go and take care of other things. Okay? I don't have to take my car and drive it because I'm at home or somewhere else. That's good. So that's very important. Now, that's not enough, honestly, so that you understand. In a normal class, you will also have at-home assignments. from homework assignments, quizzes, research has to do with projects, and reading. And usually that's the same amount, two per two. Okay. So if it's a 3 hour class, minimum, I need to be spending another 3 hour at home doing the other things. For you, it's a 4 hour class. That means there is another 4 hours. So honestly, to ace this class, you need about 8 hours. Okay. That's basically it. Granted, the 4 hours are regulated and they are on your schedule and you know exactly when they're happening. And the other 4 hours, they could happen in 15 minutes here, 45 minutes there, I don't know, 10 minutes there, so on and so forth. So the other 4 hours, the other equivalent amount of time for that matches this 4 hours need not to be on a schedule. Okay. You can basically do it whenever you are. You're doing other class, you have an assignment for English, and then you remember you have also an assignment for astronomy. So you can squeeze both of them and get them both done. So that is the plan. So the plan is you have a 4 hours scheduled plus another 4 hours, roughly, I'm not saying exactly, of extra or outside of those scheduled hours to do other things, meaning either reading, especially homework assignments, and also projects. Okay, I would say project because there will be a project. Okay, that is the plan, and also preparing for the exams too. Okay, so that is the plan. 4 hours scheduled, and you put them in your phone or in your somewhere. You post them somewhere that you know about, next to whatever other schedule you have going on. That this time is dedicated for my astronomy class. When I say it's dedicated for my astronomy class, I mean is I have to sit down, log into Canvas, and go systematically about it, open the book, and do my reading and go systematically about it. Once the time is up, you have to be disciplined. You have to get off of your chair, change your sitting, and go and do something else. If you want to do astronomy immediately after, that's fine, but you need to put a break in there because your brain needs to adjust to that. Okay? So hopefully this is clear. And you guys understand this things in here. Now, when it comes to this class, again, this section is for announcements. You already have received this sections or this announcements from me related to the this meeting. Okay, please make sure that you get to check the announcement. They should go immediately to your phone. If not, you need to go to the settings and make sure that they come directly to your email or however you're notified. Okay. Again, this is the home. From the home page, you can access a lot of things. One of the things is what's going on to do things. Okay. And the main operation for this class or any other class in general is the modules. Okay. And there are two ways of getting into it for my class, either from the landing page, which is this one, or from the left pane. So if I click to the left pane, it's going to take me exactly to where I'm supposed to. The way this class is organized is through weeks. There is week 1, week 2, and they're both available for you guys. And each assignment has a due date. This one, September 27th, which is next Saturday. This one, September 27th, which is next Saturday. This one, September 27th, which is next Saturday. And this is graded actually. You will get maximum 5 points. This two is graded 5 points. This two is graded 20 points. Okay. This one is a mark done assignment. So once you do it, you're supposed to do I'm done with it. So if I click on it and go all the way to the bottom, all I have to do is just mark done. So if I do that and go back into my modules, it should say that I did that. Okay. There is a check mark next to it. Okay. That I'm done with it. And some assignment, they have to be submitted. Like this one, you need to submit to get the credit for it. And this one also needs to be submitted to get the credit for it. This is a quiz that is due on Friday next week. Okay. So some of these assignments are quick and you need to get going with them. Other weeks, this one opens this Saturday, this 21st is what? I don't remember exactly what the 21st is. 21st is Sunday. Yeah, the weekend. So week three will open this weekend. Week four will open this weekend. And it has assignments that are coming along, some homework assignments in here, but they are due way in October. This is the maximum points on them. And some stuff that is going to be adjusted. I'm not sure, honestly, if this is correct up to this point. This assignment will open September 29th, which is next weekend. Yes, next weekend. Uh, so, for example, this is a review and it's due October 8th. And actually, if I look down, I will find that there should be, and it's not available right now. Probably I'm still working on it because there are some things behind the scene that you don't see in here because I'm still working on that. So the point being in here that this is how the courses are organized, okay? Until the last assignment, which is, I don't know why it says in here, November 17th, the November 7th, Thanksgiving, yes. So I think probably, yeah, things, again, some of you already mentioned the fact that there were some due dates, and I had to change it for two reasons. The main reason, honestly, is the fact that we needed to talk about it first, and that is today. But I need to adjust the times anyway, adjust the assignments because of the fact that we have this class ending on December 12th. So I need to make adjustments. So you will have assignments. One of the assignments that I need to talk about, and we will talk more about it down the road, is the observation, the lunar observation project. So this is a project we're supposed to go and observe the moon, and you're going to be submitting it. Okay, so there are actually more options. So this is right now, it says lunar observation. There is another project called the lunar photography, and there is another project that potentially I'll put, but I didn't decide on it yet. But you're not going to do all three of them. You're going to do only one. You'll have to tell me which project you're going to do, and you go and do it. So that's the thing with these things. Obviously, I mentioned the midterm reviews, which are actually graded assignments, homework assignments, which are graded, and actually the midterms too, which are graded too. Okay, so all of these things are graded. So hopefully you guys, we'll talk more about those down the road. For right now, the main thing that you see in here are weeks one and two. The way this laid up in here, you have the lecture notes, which are PowerPoints, okay, from the book. And then you have the video recordings, which are supposed to go through those units. In this case, you have units 5 and 6, okay? And these are from previous recordings. That's why I mentioned earlier that I'm recording my classes, the in-person class, because I want to take that one and record it and put it as a new recording for the new classes, not this semester, next semester in the spring. Okay, what did I do in here? Anyway, so they are in here. One of the things that you will notice is there is a blank recording in here, and there are also the other recordings. But this blank recording, if you notice the date on it, this is the fall 2025, section 71 meeting, September 17th, 2025, which is today. So the recording of today is going to go here. Okay, that's where it's going to go. Plus other previous recordings are going to be left intact. So my point being in here is that this is where the action is. Okay, obviously I have content for each week. So if we will look at week one, it gives me a summary. Hopefully it loads. There are some heavy pictures. Okay, and it gives you a summary basically of what you're supposed to be learning from this class, from this unit, because the way this book is divided into units. So the first units are units 5 and 6, and then 7, 8, and 9. Actually, it should have been 7, 9, and 8. Okay. And then next week, we're going to do units 10, 11, and 12, and we're going to jump to units 34, 35. So the way this course is lined up is a little bit different. So let me open another program while I'm talking. So basically, the way this course is organized, it's divided into different units. Each unit is supposed to cover a specific topic. So think of the chapters, and each book, depending on the textbook, is usually made up of chapters. This one is not made up of chapters. So the way you can think about it is, if I can get this thing down in here. Okay, now I have access to that. Trying to open the Stellarium software, which is needed for this, for my next points in here. Let me adjust it. So anyway, so the point being in here is that this is not divided into chapters, but rather into units. Think of each chapter usually is made up of different sections. So each unit is more like a section. So this, the way that this book is organized, is more like a little bit extended version of sections. So which means that the reading is required, and you will see each week has objectives. For example, for week one, the objectives is to read units 5 and 6 in the book. Okay, because they go a little bit more detailed than these notes. Okay, so you need to remember that you're supposed to be doing the reading, and that's part of the extra time that you're supposed to be spending. Okay, so because this recordings are long, they're not short. So this one, let me start it, not to watch it, but just to give me a time. Oh man, it opened a new window. So it's an hour and 19 minutes. Okay, if I start this one, hopefully here, and then stop it, it should tell me how long is that. It's an hour. No, it's not. It's not giving me the time. So I have to open it again separately to let me see if I can see it on YouTube again without watching it. Yeah, it's 56 minutes. So you're looking at about 2 hours just by watching these videos. Please don't do them at once in one sitting, because those are long videos. So don't spend 56 minutes sitting watching a video, because I myself get sleepy and drowsy and start to probably drift, okay? So don't do that, okay? So, and that's part of the reason why I'm redoing the recording, is to allow for them to be broken down into smaller sections so that you guys can skip in between. So try to break them, I mean, each hour into like 15-minute sections. You watch the first 15 minutes, you look at the book, you look at the notes, you do the examples, and then you move to the next 15 minutes or 20 minutes or so, and then you finish the video, hopefully covering all of the content, and then you move to the next one. Okay? So that's one way of extending this 1 hour session into about 2 hours. Okay? By doing the examples in it and watching the video and going around, taking a break, probably 5-10 minutes break, normally how we do it. And then you go on another date, you do the next video, and you're done with both of the units here, okay? And let me go back to the models. And this is true for almost every week. Some weeks they have more recording than others. Some weeks they have less recordings than others. Some weeks they have more assignments than others. Some weeks have less assignment, depending basically if we have an exam or not going on, okay? Some of these discussions, or most of them, are graded. Some of them you will notice that they are not graded, especially toward the end, like discussion 10 in here has no points in it and no due dates on it because it's not graded. So you have to, in here, there is no discussion at all, okay? And this is an assignment that it has a due date and a graded assignment. So you need to be aware of your environment, of your surrounding at all times to basically make sure you progress through this class and you complete everything, okay? So the reason why there was some jumping going on in here is because the class is divided into different sections. So the first tool is, so let me stop sharing this and let me share with you guys the other screen. Share. Where is the share button? Here. And share the Stellarium software. Okay, it's on the screen. So basically this stuff, some of you are sitting in my astronomy labs and this looks familiar because it's the same software. This is the Stellarium software that is actually in the lab too, and we use it. We have other tools also we use in that lab, but this is one of the tools. So what do we learn in this class? First of all, we learn about the tools used by astronomers. One of the tools that is used by astronomers is, of course, geometry. So we learn extensively about how we locate objects in the sky, using coordinate systems, whether we're looking at the basically an azimuthal grid or equatorial grid, basically the right ascension, the declination, all of the ways that we may find locations of objects in the sky. We make ourselves more comfortable in understanding what do we mean by the local meridian, the prime meridian, and also the ecliptic, if I can find it, okay, in here, which is the path, the apparent path of the stars and the planets. I mean, the stars and the planets. Apparent path of the sun and the moon and the planets, okay? But stars don't have to do any of that. And it also gives us how astronomers know what they know, basically using spectroscopy, using light and properties of light and things like that. So we use tools used by astronomers, which is kind of what astrophysics is. Then we're going to learn more about the solar system. So we're going to focus more on how we divide the solar system into different sections. One of them are the inner planets, okay? So the inner planets, of course, include Mercury, Venus, Earth, and Mars. We study Earth, of course, that's home. We study another representative from the inner planets. Turns out I chose Venus. The reason why I like Venus is because it's similar to Earth in many ways and also different than Earth in many other ways. So there's similarities that we need to understand. Basically, we extend what we know about Earth to Venus, and then we see some drastic differences. One of them is the rotation of Venus, the fact that it doesn't have a magnetic field, there's tremendous pressure, and it has a runaway greenhouse effect. So it has all kinds of different things than Earth. The same mass of the Earth, roughly, same size of the Earth, same gravity, same location almost in the solar system. Those are the inner planets. We take the moon, we study the moon, and actually that gives us a chance also to look at the moon and how it looks like to Mercury, because there is a similarity. They're not too different in size. I mean, Mercury is bigger, but the moon is not different, at least in form. Okay, they all are heavily cratered objects. Okay, and there is a relevance into that. Then we study the outer planets. The outer planets, of course, we have the two gas giants and the other ice giants, and all of them, they're made up of the same structure. All four of them, they're mainly hydrogen with helium as a second main component, but they have also other gases like methane and all of the other water also and things like that. There is a line that delimits between inner and outer planets, and that is the frost line. So we'll learn about how the solar system is structured in terms of these big eight objects: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Those are the eight planets in the solar system. Then we study the moons in the solar system. We already have explored the Earth's moon, which is a big odd thing in the inner planets because inner planets usually don't have moons. With the exception of Earth that has a big moon, Mars has two tiny captured asteroids, so they are not really moons. The other two don't have any moons. But the outer planets have a lot of moons. Moons that are, in the case of the two outer ones, that are at least two, 3 dozen moons, and two hundreds of moons for the case of Saturn, especially, or even Jupiter. It has some 70 some odd moons. Jupiter, though, has four big moons that we're going to study extensively. We have the biggest moon in the solar system, which is Ganymede. Ganymede is so big that it's even bigger than the planet Mercury, so that you know, it's a big moon. Had it not been orbiting Mercury, it would have been a planet far more important than even Mercury, because it's a big planet. So Ganymede is a big moon. The other moon that we're going to study is actually not from Jupiter, but rather from Saturn, and namely Titan. Titan also is a big moon, and potentially it has life on its surface. I mean, albeit not a carbon-based life. So that's one of the things, missions of NASA in the future, and also the European Space Agency, ESA. So that's something that they're planning very soon, actually. Within next less than a decade from now, they should be exploring that moon. And that's Titan. Titan is so big also, it's bigger than the planet Mercury, so that's two big moons. The third moon in terms of the size in the solar system is actually Io, which is another moon of Jupiter, and it's bigger than uh, than no, it's about the size of Mercury actually. So it's a big moon. The third moon is going to be Europa, and the fifth moon in the solar system we already have seen it, that's the Earth's moon. So those are big objects in the solar system that we're going to explore, plus a lot of other moons. So that's part of another structure of the solar system. We're also going to study the asteroids, namely the asteroid belt and the Kuiper belt. It's made up of a lot of rocks. Before that, there is actually the dwarf planets that include Pluto, Eris, Makemake, Haumea, uh, Sedna, and about a dozen other dwarf planets. So those are big objects, and they're so interesting. They're actually world in their own. They're basically as important, if not more important, than a lot of other planets because some of them have moons. Like, for example, Pluto has 5 moons. One of them is a huge moon. Okay, so we'll study the dwarf planets, the moons, and also the asteroids, and also among the other objects that we will explore is the Oort cloud and also the uh, life-giving or life-ending objects on Earth at least, and those are comets. Okay, so those are some of the things that we explore. Then we move on to the sun because we're going to move. That's why the units are jumping all over because we're going to pick up topics in here. One of the objects that we're going to study is the sun itself. Okay, this is its outer shell and how it looks like. It's made up of dark spots, as you can see, plus the other zone in here. This is a hotter region than the dark spots, and we will see what's going on and what makes this one tick, what's so important about them. And then we also uh, dissect the sun and go all the way to its core and see what's going on in its core. This gives us an idea of how normal stars are. Okay, so this is the star, our own star. By the way, this software can give you a lot of things. I don't know. This is the Mercury. So if you look at Mercury in here, and this is one of the objects. And again, I mentioned in the beginning that it's going to be part of something similar to the moon because you look at it looks not too different from the moon in terms of its surface and how it's heavily cratered. Okay, let me stop the time because I don't like the way that these things are drifting in space. Okay, and another object that we're going to study is when we study them, of course, is going to be the planets, and that is Saturn with its own rings. Okay, but before the ring system itself is actually an important topic as you start zooming in, and this is you do it actually with a telescope. Once you do a telescope, my telescope, which is a 5-inch telescope, will show me Saturn and Titan at the same time. I don't see Dione or the other moons, Iapetus or any of the other moons, Enceladus. Those are important moons. But the Saturn nowadays, it looks like this. The rings on it don't look too important because it's on its side. We're looking at it this way. So this is Saturn. And one of the structures that is important for Saturn is this bands. They're not as drastic as they are on the case of Jupiter, but this is a common theme for all of them. They have this structure in them. So again, if you look at Jupiter now, again, once you look at a Jupiter, even with my 5-inch telescope, you will see the other 4 moons. Io being the closest. Ganymede is actually the third one. Europa is the second one. The reason why it looks like Ganymede is closer, for those taking my astronomy lab class, you will do an extensive lab on this object, trying to find the mass of Jupiter using all of these 4 moons. So the what's going on in here is that these things are orbiting. So right now, Ganymede looks like it's closer, but it's not. It's far away, actually, because there is an element of depth that we're missing in here, okay? So, and this is the band. So of course, Callisto being the furthest one away from the from Jupiter. So again, this is the band structure. It's far more drastic in the case of Jupiter than any other outer planets, but it's true for all of them. They have bands like this one. One of the objects that captured the fascination of a lot of people, and it's not visible because the planet is spinning on its axis, and that is the big red giant spot that is on the surface of Jupiter. So we're going to study a lot about the solar system. As I said, then we move to the sun. Once we learn a lot about the sun, we're going to take what we know about the sun and study other stars, okay? And of course, constellations. One of the interesting constellations, we have them divided into three. We have the circumpolar constellations, the one that go around Where is now I completely messed up this thing in here. I don't know which way is north. Here is north. Here is Polaris. Okay. So some of these constellations will be spinning around Polaris. So if I animate this thing in here and get it going, you will see that the stars actually start to spin around Polaris. That's due to the fact that the Earth itself is spinning. Polaris is not spinning. None of the stars is moving, actually, at least at this rate. It's the Earth spinning around its axis. It gives me the effect that everything is spinning in that direction. The Earth is spinning this way, giving me the impression that everything is spinning in the opposite direction. Okay? So if I turn on the constellations, we're going to learn so much about the constellations. One of the things that we're going to be learning about the constellations is, for example, you have Cassiopeia in here, and you have these constellations which are called circumpolar constellations because they go around Polaris. And you have others that are part of they go around the ecliptic. They're actually part of the zodiac sign, and they have names that are 12 of them. Actually, there are 13 of them. There is a 13th sign of the zodiac that is because the sky is so large that you need an extra one. Anyway, and there is ones that are regular constellations. So we're going to learn about that and how that's relevant. So let me stop this dizzying thing in here. Okay, and let me remove this thing in here. Anyway, so we're going to learn so much about this one. Of course, we're going to learn about the Milky Way being a galaxy. We're going to move on to the galaxies, the Milky Way, and another galaxy in here. Let me try to find it. Okay, it's not there. Okay, here she is. Of course, this is Andromeda Galaxy, okay, which is our biggest neighbor in the neighborhood. And at some point, these two galaxies, they will collide. So let me stop the time. Okay. Milky Way and Andromeda will collide. There is another galaxy in the neighborhood too. There is actually more than these galaxies in here. There is if I can start to zoom in. No, that's not the one. I'm looking for another galaxy called the Triangulum Galaxy, which I don't see it. It should be not too far from Andromeda Galaxy. Is it this one? Yeah, this is the one. This is actually the third largest galaxy in our immediate neighborhood, okay? And the three of them, Triangulum, Andromeda Galaxy, and the Milky Way, they will collide in few billion years from now, okay? And that's after a long time when the sun goes away, okay? So if you're trying to find it, let me turn on the constellation. If you want to see it at night, okay? Uh, okay. So let me try to find the common thing in here. Which way is the north? That's the west. So it's going to be to the northwest, okay? In our horizon, let me put the horizon back. Oops. So again, when you're looking west, okay, to the north, so you have the north, you have the west, and just almost northwest, okay? This is the time today. We're looking at September, what date is this? September 18th, which is tomorrow at 7. No, 7 is too early, okay? 7 is too late. Anyway, because I turned off the daytime, that's why I don't see the effects of the sun, okay? So this is the time. Anyway, you can trace it in the sky and you can find these objects in the sky, okay? And that's part of this class. We're going to learn about galaxies and how galaxies interact. They collide with one another, they consume one another, and the Milky Way is actually has consumed several galaxies in the past, and it's in the process of consuming some more. Two of them, of course, are the Magellanic Clouds, the big and the small one. And so there's some processes going on in here which are called which is kind of a cannibalism, basically, where galaxies each I mean consume one another. And then we have also, we're going to look at the big scale, which is the cluster of galaxies, the supercluster of clusters of galaxies, and the entire universe. One of the questions at the end we'll be looking at, and that's why this course is divided into units, as I was saying, is basically explore life outside of Earth. Okay. One of the options that we're going to be looking at is life actually in the moons, like for example, I mentioned before Titan. This is one of the objects that is of heavily explored nowadays. Also, Europa has a very good chance to have also life and carbon-based life, just like ours, okay? Because of its huge amount of water and oceans underneath, far more than what the Earth has. And also, another possibility is life could exist other than the moons of the outer planets. Also, it could exist on other outside planets. And this is one of the missions of the James Webb nowadays, is to explore the upper atmosphere structure of these exoplanets, planets that are not part of the solar system altogether. Okay. And we'll study that. If you're taking again my Astronomy 125, one of the labs deals with the first exoplanet that was ever discovered. So we're going to go through the discovery of that exoplanet. We'll determine its size, its mass, and its physical size. And we will see actually it's going to be a Jupiter-like planet. It's a huge planet, so it's not a small, tiny planet. And so we're going to study the exoplanets in this class in terms of, especially in terms of their habitability, in terms of how suitable they are for life, suitability for life. Okay. So we're going to explore that. And that's how we end the class. Okay. So this is the entire astronomy class. We're going to hopefully have a fun semester. Hopefully you guys take care of business in terms of, doing the assignments on time, in terms of making sure that everything is ready, everything is done on a timely fashion. And if you have any difficulty, you hopefully you reach out immediately. I mentioned homework assignments. There are a lot of resources for those homework assignments already on 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 uh, on my channel. If you go to DJ Buzidi on YouTube, you will find a lot of homework. The only thing I ask that you do when you go there is search for astronomy homework. Okay, don't search for homework because I have so many classes, so many videos in there. It's not even funny because I have other classes. Some of them have to do with my engineering physics classes. Some of them have to do with my other physics classes. And some of them have to do with astronomy also. So try to zero in on the search. Otherwise, you get a lot of basically you spend so much time basically going through those videos. Those videos are actually also going to be provided in the weeks concerning those homework assignments. So you really don't need to go and search on YouTube. You can come through straight down through the Canvas shell. Okay, so you should be able to find those resources. If none of those help, please reach out and say, you know what, I can't find the help for it. Here is the funny part, and it happened last semester, okay, last spring. I have homework assignments. I receive a bunch of basically replies or responses to those homework assignments, identical with the symbols and the wording and everything. I don't have a problem with that, okay? As long as you know what you're typing. So if you get somebody else to do the work and he or she was willing to share that with you guys, that's fine. That's not the objective. The objective is not to get the things right. The objective is to understand what's going on. Okay? For science in general, especially physics and astronomy, are based on numbers. You don't know anything unless you have a quantitative measurement for it. Once you have a number associated with it, then you have a way of rationalizing that. That's how it sticks. That becomes knowledge. Okay. But if somebody else is doing the work and he or she is sharing it with you, and all you're doing is just basically changing their name sometimes and putting your name on top, that is not learning. That is, you're doing a big disservice to yourself. That's one thing. The funny part is there was some equivalent number, similar, identical responses with symbols and everything, and wording and everything, but they are wrong. I did not run it through an AI analyzer to see if this was AI generated. It seems to me afterwards that that's exactly what happened. Somebody, instead of doing the assignment, went to ChatGPT and put the assignment in there, and ChatGPT's generated the answer. ChatGPT made an assumption in this case, and that assumption was wrong, so it got the answer incorrect. And another one, another version of either ChatGPT or another AI, made a different assumption, which is the correct assumption, and got the answer correct. Okay? So you need to, if you're going to do artificial intelligence, you need to know what you're doing because artificial intelligence is nothing but a model. Okay? And that model has some sort of underlying rules. And if you don't understand what it's doing, it may lead you astray. It may give you the wrong answer because it had to make an assumption of some stuff that is related to the class that it didn't know existed. But in the assignment, it tells you about it, so you forgot to include that to ChatGPT to teach it onto how to do things. So what happened in this case is those half of the students got the answer wrong because they relied on an answer that was provided based on the wrong premises, based on the wrong assumptions. Okay? Whereas others, they got it right because probably they fed the correct information to it. Or the AI in that case model made another assumption which turned out to be the correct one. Okay? So my point is this. If you are going to go to the STEM center, which I highly encourage to do, or going to somebody else to ask for help, or going to artificial intelligence and ask for help, you have to know what you're getting. You have to understand what you're getting. I don't have a problem with whatever you're doing, okay? As long as you know what you're doing. Because at the end of the day, it's you and you only are the one who's going to be judging yourself. Come exam time, you will not have access to the resources, so it's going to be a problem. And at the end of the day, did you really help yourself? That's the question that you should ask yourself. Okay. So basically, again, you will have assignments. I would hope that if you have difficulty with the assignments, and you do quick research because the last thing I would want you to do is spend a lot of time not understanding what you need to do. Watching basically the assignment is asking you to do this, but you can't even get it started. Don't spend too much time on it. If you can get going with it, fine. If not, reach out. Tell me, hey, I'm looking at that problem from homework 2 or 3 or whatever, and it's asking for things that where would I get started and where is that information? How should I go about it? I direct you to a video that is in there. I watched that video. I still don't know how to do this thing. Where do you put those numbers from? Okay. Then we'll meet and discuss it. And hopefully you yourself, you come out of that and say, okay, now I know. And that is the key. That is really the important thing. Now I know how we got that thing. Not I know what that thing is. That's not important. I know the size of that object because you're going to forget it. Okay. And if 6 months from now somebody asks you for it, you're going to forget it. You're going to Google it. Okay. The mass, the object, the whatever the question was. So that's not important. What is important is I know where you got it from. I knew the thinking of how you thought about it. I know how it has to be done. Okay. That's the key. It's not about the end game, it's about the process on how to get there. And that's how science is. Because facts evolve as we have more tools, we refine our models, and we come with better explanations. Case in point, what we have in this class. Part of the objective of this class is to learn the scientific method and how people think. In the old days, people looked at the path of Mars, and they saw that Mars sometimes moves like everybody else, and sometimes moves back. So they called it the retrograde motion of Mars. Well, they thought that maybe something is really going on in here. So in the old days, people thought the Earth goes around the sun. That was about 2,000 years ago. Then Ptolemy came in, and a lot of people they were influenced by basically philosophy and religion, and they thought, no, the Earth actually is the center where everything goes around it. But how can we explain the rotation of Mars, the fact that it has to go retrograde? So Ptolemy suggested, actually, he did not suggest that idea, but he borrowed it from somebody else, but he perfected it. And he thought that because circle is a perfect shape and everything has to go in circles around the Earth, but now he suggested that it's going on a circle he called the epicycle, and that circle is going around a point, and that point is the one that is going around the Earth in a circle. So at some point, that Mars is going forward in a prograde motion like everybody else, but sometimes it's going backward because it's going in its own circle. And that model worked for a long, long time, for about 1,000 years. Worked beautifully. I mean, it started to show its weakness because the calendar starts to get messed up, and Copernicus was asked to fix the calendar. So Copernicus started to see some weird stuff, not just for Mars, actually, for Venus also it does something similar. And he went back to an old idea where maybe the Earth is not the center of the solar system, maybe the sun is. And when he put that into the picture, everything fit in perfectly, as long as Mars is moving slower compared to the Earth, and the Earth is overtaking it. So now we understand why Mars at times appears to be moving backward, because the Earth is overtaking it. Just like when you're driving on the freeway and somebody's going slow and you're passing him, you see them as if they're moving back, but it's you moving faster than they are. Okay, that's it. Okay. So that explains the retrograde motion. So my point in here is, it's not about the end game. Now we know the Earth is actually moving around the sun, okay, based on this thing. But the process, how we get there, that is actually more important. Because this process of thinking can lead us to other things. As, for example, the force of gravity causing planets to go around the sun. Of course, that's basically the model we have. But if we go with it, we can understand everything but Mercury, for example. There is a problem with the path of Mercury. Everything will move according to Kepler's laws beautifully, no problem with it whatsoever. But the path of Mercury, although it goes also in elliptical orbit, that elliptical orbit precesses. It changes over time. So it's not on the same plane. The plane itself is wobbles up and down. So that led Mr. Einstein to another theory that abolishes everything before it and came up with something else to explain not just the path of Mercury, but everything else too, and led to new discoveries. Among them is black holes and things like that. So my point being in here is the process, not the end game, because things evolve. Our view of things evolve. Our understanding of reality changes. It's not the numbers at the end. It's not it's how we think, how we go from place to place to place to place, and how we progress. And that is part of the objectives of this class, is to learn the scientific method and how scientists work. I know this is a general education class, general science class, where people learn. Hopefully, they have fun in the process, but part of it is actually to learn about the scientific. Okay. Okay, this meeting was scheduled for an hour and 15 minutes. Right now, it's an hour and 10 minutes since we started. If you guys have any questions, please reach out. Okay. I will have more meetings down the road, especially discussing specifics related to the exam and projects and things like that. If you can't make them, again, I mentioned that in the beginning, you need to watch the recordings. Okay. If there are no questions, I'm going to end, first of all, the recording, and then I have a discussion with the attendees. Okay, let me get my mouse. What is the recording? Stop recording. Okay, I'll see you guys later on, okay, for the others, okay? Thank you.